Bismillahirrahmanirrahim. So, this chapter is about life expectancies, but actually, it's about a bigger issue than that. And the bigger issue is the one that most people who take statistics never really understand, and that comes from the positivist approach, which just looks at a number as a number. But actually, there are two types of numbers. There are objective numbers. Objective numbers are part of external reality, and they are the same for everyone. And the subjective numbers, everyone has a different view. So, for example, if I say, what do you think of the Karachi city? Is it a good place to live or a bad place to live? So, everybody can have their own opinions, and there is no objective truth about this. On the other hand, if I ask how many trees are there in the forest, then this is not something which is subject to opinion. So, one of the theories of probability, the Bayesian or subjectivist theory, says that probability is just an opinion and everybody can have a different opinion. So, this is not a useful way to think about probability, because when you flip a coin, the probability is in the coin, it's not in our heads. And not understanding this distinction leads to many different kinds of mistakes. So basically, normally the statistics that are studied, and in fact in previous versions of course I was also using this, is the GNP per capita. Now the GNP is a real statistics in the sense that the GNP tries to measure something which exists in external reality. What is that thing? If you look at all market transaction, everything that was sold in the market to consumers, this is called a final good. So if you take, for a given year, if you take all of the things that were sold and you look at the money that was collected and you add all of this money, that is the GNP, or actually the GDP. So that is a real number. It measures something. It's a different question as to what this number means. So if we ask what is the corruption level in Pakistan, then this is not a real number, in the sense that there is no objective reality which is being measured. So the way that the perception index works is that you take the opinions of a panel of businessmen as to what they think about corruption in Pakistan. So according to what their opinion is, that is the ranking of Pakistan. But this is something that is not an objective characteristic of Pakistan. If I tell somebody that go out and measure the corruption level of Pakistan, that will not give him, everybody can come up with different numbers. So this GNP per capita, GNP is a real number, but GNP per capita is not, because GNP per capita is a concept which says that take this, all of this money and divide it equally among all of the people in Pakistan. So this second step, where we divide by the population to make an equal division, this is a myth, an illusion. It actually deceives people into thinking that the number sort of represents what everyone would get if we took all of the income produced and divide it equally. So this is a idea about that. This is an idea we have, and there is nobody in the real world who actually has that GNP per capita. So that is illusion, and it's a useful illusion because it hides the fact that wealth is concentrated into a few hands. So if we were to break up income into quintiles and take each quintile, then we can say, okay, this is the income of the top 20% of the people. This is how much money they have. And then the second quintile, this is how much. So this is this is a real number in the sense that it is an objective measure of something which actually exists in external reality. So this much is enough for an introduction. So what I was saying is that normally people analyze GNP per capita, but this is not really a feature of external reality. It's a subjective view of what some people think is a good measure of the prosperity of Pakistan. And most people who have studied this agree that this GNP per capita is not a very good measure of the prosperity of Pakistan. So I didn't want to study something like that. So I chose a different number, which is called the life expectancy. And a life expectancy is a real number in the sense that it measures how long we think the people are going to live. Now, unfortunately, this cannot be measured. Although this is a real number, this is something, I mean, after many, many years, we'll find out the average age of the people who are living right now. Some of them will die soon, others will die later. And if we take the average amount of time that they live, that is the life expectancy. But since this is in the future, we cannot measure it. So when we look at life expectancy number, this is always a guess about what is going to happen in the future. And all such guesses depend on some assumptions. So even though it is a feature of external reality, it is not a number which can be measured because we don't have the information about the future. So there are various ways to estimate. And so the real statistician should be aware that, okay, this is a true number, but the number that is printed in the World Bank table, it is not an objective number. It is an estimate of something that is actually real. This estimate depends on some assumptions. If we change the assumptions, we'll get to different numbers. But this is one number which is actually measuring something meaningful as opposed to GNP, which, in my opinion, does not measure anything meaningful about the nation. So that's why I chose to study life expectancies instead of GNP or many other numbers. So, okay, with this preliminary, I would like to start our presentations, starting with Group A. So, who's going to present for Group A? Is it Saira? Who is presenting for Group A? Yes, I guess it's Saira. So go ahead.
Assalamu alaikum.
And I would like to ask other members of the group to take up the burden and prepare. You have 2 weeks to prepare the presentation. So if you can't do all 4 questions, then what you should do is to take just 1 question so that everybody participates. All right, Saira, you can go ahead.
Assalamu alaikum. So I'm sharing my screen. So can you see my screen?
Yes, we can see your screen now.
Okay, the first question was about the calculating the life expectancy. You gave us a table in which you said that in the table there was an age of different people, of people of your family members who and how much they aged. This was the information given in the table. I can show you the table.
Yes.
Let me show. So this was the table in which the family members from both sides of a child of newborn was given, like from the father's side and then from the mother's side. So basically, what we did, we make the classes and different age bins. We can call them age bins or the classes of different ages from a different age. How we make the classes? We just take the lowest. We just take the lowest number from the data and then we take the highest number and then we make the different classes and then we calculate the frequency. We just see that in this we are saying that how much people survive to this age. So basically the only uh, 4 people survived to this age, like how much people died to this age, like it's around in this group, this is the 60 to 70 of age. So how many people died around in this age, like they were when they were in between 60 to 70. Then similarly 70 to 80, 1% died, and in between 80 to 90, 6% died, and then 90 to 100, 2 people died. So that's how we calculated the frequency. Then we took the median, and according to the data, the median was 80. So basically, the largest possible age we are giving is 80 years. It is because of the median. And then the lowest possible age we are giving is 60 to 70 because 13 people survived to this age. Now, moving forward, there is another way. This was the median.
Okay. Asir asked a question about the bins. So is it 71? Well, yes, actually, the it should be 60 to 69, 70 to 79, and so on. So 70 can be the beginning of 70 and yani 70 minus and then entering into 70, but this is not important for the exercise.
Okay, there was
No,
another.
actually, I didn't mean to
GG.
have overlapping classes, although that's another issue. These are not meant to be overlapping classes. These are meant to be separate bins.
Okay, you are asking me to make it 60 to 69 and then begin other with 70 to 79. Then like this, because 70 is
Yeah,
coming
well,
in
no,
in
that's a
both
fine
classes.
point, and no, actually, I think you can ignore this, but the actually technically you should keep the edge bins separate. And I actually wrote these numbers in the wrong format, but this is a minor issue. It will not make any difference to the numbers that you calculate actually. So go ahead. No, I'm not saying, I'm not asking you to make any changes.
Okay, so there was another way in which through which we can calculate it is I just calculated or computed the range. It is this range I took from the table. I just said that the life expectancy is between 61 to 78. 61 is the lowest age, and the 78 is the largest age. So basically, why I gave this range is because the lowest age for people of the family member survived is to around this age 61. This was the lowest age the family members aged. So basically, this is 61, and the assumption I'm taking for that is that the people transfer their living style to their newborns, to their inheritors. So basically, if they are transferring the same, inheriting the same lifestyle, so that means the people are going to the new generation is going to age same according to the way they age, the number, the amount or the quantity the number of age they had. So this was the assumption. And then about the lowest age, it was that I just straight away took the lowest age from the data and just said that okay, the newborn is going to survive to this age.
That's
So
very good, Saira. This is illustrating what I was trying to teach, that when you are writing the statistics, you can make many different kinds of assumptions. So you can say that, okay, uh, this under this kind of assumption, we get this number. And then when you, at the end, you just present the number that it's the life expectancy is 65 according to my calculations. You don't explain how you did the calculation, although you may have a footnote in the paper that to get this number, I made such and such assumption. But when you say life expectancy is 64, everybody thinks that this is a number, so it is calculated, and you can't argue with numbers. So this is one of the ways that people deceive us with statistics. The number looks very, very strong and healthy and factual, but actually it has been cooked according to assumptions. And any number that you calculate for life expectancies will automatically be forced to make assumptions because nobody knows the future. All right. So go ahead.
Okay, the second question, in second question you also you gave the table in which you said that this is the imagined table. This is not the actual table in which there were different age groups, and there was the reasons for their death. There was some natural death. There was like, for example, if war is going in Afghanistan, so there was some war related deaths, and due to the malnourishment, there was some people died because of disease, and some people died a natural. So how this natural and deaths is different? I wanted to ask this.
Oh,
That why this?
well,
Okay.
I mean, natural death is when people don't die of war or malnutrition or disease. They just live and then they die without any because of old age, without any particular cause. The heart fails, or so. When you are predicting life expectancy, then you can make different kinds of assumptions about what will happen to disease, what will happen to war, and so on. So this is again another way to uh, show how our assumptions affect these numbers.
Okay, then you gave the two scenarios in which you said that if the people are going to age till 21, so now what will happen to newborn? What will happen to the life expectancy to the newborn if there is a, like, how many people died because of war? So we are stopping at the age of 21. So that means that 100 people are going to die at the age of 29. So the life expectancy will be 12 years. Moving forward, we calculated the life expectancy as you explained in your example. That was the example you gave us, that, for example, we are going to take 1,000 people, and out of them, we are assuming that lived for 5 years, and out of them, only 150 lived for 5 years. So we are going to say that age lived on the earth by these 15 people, 150 people will be 750 years. Moving forward, then we are left with 850 people. Out of 850 people, for example, 10 to 20, and the people who lived in there 10 to 20, and the 500 people survived to 20 years. So the age lived by these 500 survival is 5,250. So now we are left with other 350 people, like out of sorry, 350 died, and they aged till 15. Then out of them, the 500 people, 400 died at the age of 25, and then the age lived by those 400 people is 10,000 years. So now we are left with 100 people, and for example, they lived for like 35 years, and the age they lived on the earth is 3,500. So we are going to calculate the average and divide it. We are going to calculate the sum, and we are going to divide them with the 1,000. This is how we calculate the average. So we will compute 19.5. That means that the average life expectancy will be 20. So these are different ways of calculating the life expectancy. One of them is that you can calculate in this way, and like you are changing the scenario. If the scenarios are changing, that means the life expectancy is also changing. So we say that data doesn't lie. So data is giving us a number. In which circumstances that number is coming from which circumstances that number is coming, we don't know. So in some cases, there is a war happening in the country. Then what is the life expectancy? If we are going to apply that particular life expectancy during the days of peace, so it will be like give us wrong information. The way you said in last class that if someone will ask you if you are a police, if you are one who is collecting the data, and someone will ask you that why you are saying that you have to collect all the data, and then you said that you will tell them that I am doing this because this is my job, is to give you a data. So my job is not giving you a partial picture. My job is to give you a whole picture. So I have to tell you, I have to give you the scenarios as well. The whatever context I'm collecting that data, what is happening in that country, what is the facilities provided to the people of that country. We have to inculcate all those factors as well. So the third question was about the if we are going to say that we are eliminating some part of them, like so for this is the same case, we are eliminating the people, the war related deaths, we are eliminating the nourishment, deaths because of malnourishment, then what is the life expectancy? So according to that, 60 people who are more than 60 people, 60 years, they are going to survive. Out of like 50, around 50 people will survive till 60s, and then even more. So basically, we have seen the same data from three different perspectives, and we came up with the three different life expectancies. So here we are saying that the how data is deceiving us. So the third question in which you actually asked the theory behind this whole exercise, maybe this is what I am guessing that you asked. So you asked that how these numbers are telling us about the quality of life and then impending the climate catastrophe. So basically, if we see that they are just giving you a aggregate number, they are just giving you one number. They are not telling you that the reason behind the person's death, maybe someone has died because the ambulance couldn't reach that person. Maybe that person died because he didn't have the money to go to the hospital. So there are different reasons behind those deaths, but then they have a climate issues. So if the data is collected by from the people who are privileged, then we can say that, for example, from in Pakistan, if we are going to see the life expectancies for rich people, so it will be a different number. Similarly, if we are going to see that how the poor people are living, then what is the life expectancy, and we just make it the life expectancy of whole Pakistan, then it will be a different case. So this was from our side.
Very good. I would like to add one remark here.
Yes, sir.
And you have picked up the correct answer, but just to make it clearer, actually, what is going on today is that people understand that capitalism produces very, very bad results, but then they say that it doesn't matter because life expectancies have gone up. So it means that everybody is living longer. So regardless of pollution and climate and everything else, people are living longer, and this is an objective fact. And so we should consider that capitalism has produced a good result. Now, if you think about how capitalism works, basically it converts human beings into human resources. So people are now just working and working and working and producing money for the capitalists. Now, in this situation, suppose, I mean, if you think about that people have become slaves, and then the slave owner is very concerned about the health of his slaves because he wants them to live longer and be healthy so that they can produce more. So he makes them live longer. So can we say that this is a good thing? Well, if you take into account the uh, saying of Tipu Sultan, he said that life of one day as a lion is better than 100 years as a jackal. So just yani the increase in life expectancy numbers, together with lots of statistics which show that the quality of life has uh, become worse. People are committing suicides, alcoholism, depression, loneliness, all sorts of psychological disease. So this is not sufficient to argue. So in this course, statistics, we're not saying that you should just look at the numbers. We're saying that you have to look beyond the numbers and you have to learn to think about the meaning of the numbers. So if somebody tries to argue that capitalism is good because it's increasing life expectancies, so there are two things to check. Is life expectancy an objective fact about the real life? So in some sense, it has a degree of objectivity, but also it is calculated according to assumptions. So one has to think about that. But if we take that as an accurate calculation, then we still can say that the even if this is accurate, it is not a correct reflection of the prosperity of a nation or even the uh, overall well-being of the people. It is a reflection of how long they live, but it is not a reflection of how well they are living. So all of these things are not things which are taught in statistics courses. In fact, students are taught not to think about this. They are told that the job of the statistician is to think only about the numbers and let the anthropologist or psychologist or economist think about whether the people are living well or not. But I'm saying this is wrong. When you are analyzing the numbers, you have to analyze the numbers within the real world context. You can't isolate analysis of numbers from the analysis of the real world. All right, so we can go
Sorry,
on to
one
section.
example is also
Yes,
coming in my mind. If you allow me,
yeah.
can
Yes,
I
please
share?
go ahead.
There's
Yes, please.
another thing, there is another argument we hear in the favor of capitalism is that employment, that capitalism is increasing the employment rate. But we are not seeing that how the employees are living. They are saying that it is fulfilling their financial needs, it is making their family happier. So how you can say that capitalism is bad? But when we see the kind of life an employee is living, that is like horrifying. That is like they are living very bad life and they are doing suicide as well.
Yes, you are right. The problem is that we need to provide an alternative. People say that, yes, you are right, that in an ideal world, we should be looking after each other. And in that world, these things would not be happening. But we haven't actually created a living model. So, this is our job to do to show that how we can create better conditions, economic for everyone, with justice for all. And it is possible to do, but one has to have a vision and a drive and work to create such outcomes. All right. So we go on to
Thank
group
you, sir.
B.
Thank you.
Thank you for the presentation. So who is presenting from group B? Maz, yes. Go ahead.
Assalamu alaikum. I hope the screen is visible.
Yes, I can see your screen.
Assalamu alaikum. Okay, so the first of the questions that was assigned to us, it was about that what are the assumptions being made in the coherent method to calculate the life expectancy. So it was one of the methods that you have discussed in the lecture. And the assumptions that were made in this method was that if for example, the first of the assumptions is that if there are certain numbers of deaths over some years, then we can actually distribute these number of deaths for each year over the whole time. So, for example, if in one decade, if 200 deaths are there, then we can actually maybe redistribute these deaths or subdivide these number of deaths equally for each year, and then we can calculate the rate for each year. So this is one of the assumptions to calculate the life expectancy through coherent method. And the second is to equalizing the number of deaths. It will lead us to the increase in the death rate. So it was the result of these assumptions that when we are going to subdivide these numbers on the annual basis, and these numbers are equalized over the years, then the death rate is going to increase. So we have two ways to deal with it. Either we can basically have uh, a real data about the mortality rate, or we can actually equalize the rate, the mortality rate at which the this number of deaths are being equal to the actual data. So these two methods are being used while calculating the life expectancy through this method.
Well, actually,
Uh,
the key assumption is that the cohort, I mean, the people aged, if people aged 50 to 60, 20% die this year, then the same thing will happen next year, that people aged 50 to 60 20% will die next year. Now, this is a problematic assumption in the sense that we are making a forecast about the future, but we don't know. But roughly speaking, we can expect it to be true. It's not a disastrously wrong forecast, but it is just a guess about the future, that the future will be like the past. And this is the case with many, many statistics that we make a guess. And then, but when you produce a number, it seems like a objective fact about external reality. All right, so go ahead.
Sir, is it due to lack of availability of data or what?
Well, who can tell how many people will die next year?
Mhm. Okay. Okay. The next question is to list some circumstances which could happen in the future, which would actually cause these assumptions to be wrong. And these assumptions were, I mean, that here these assumptions in these questions mean that whether expectancy rate will increase or decrease and how these are being calculated. So one of the circumstances can be to change in the living styles and habits. For example, if the number of maybe if I can wait
Yes,
for
this is
Azan.
correct. Oh, no, Azan, yani, the people are all over the world. So,
Yeah, yeah, sure. Actually, I hope I am audible. Yeah, that's okay.
yes.
Okay, so the first of the assumptions is that change in the living style of, for example, in the future, if people are more becoming more habitual for smoking, then of course it is going to impact their life expectancy. Similarly, if one of the circumstances could be that if the people are getting less preference to getting married and having children, then of course over the time it may also lead to a decrease in the life expectancy. Then if the advancement in health innovations are being made, then the survival rate being increased for the newborns, then it will increase or it will have a positive impact on the life expectancy. So we are not
The first and
certain that,
third are correct, but the
yes,
middle one, if people have more children or less children, this will not have any effect on the life expectancy calculation
yeah,
because where life expectancy is saying what is the average age of the people who are living this year. So whether they have children or not will not affect the average age of these people.
yes, got it. Thank you. Okay, the next question is to give some examples of how economists basically use sophisticated mathematics to impress rather than to make a good argument. So what we have perceived from their actions is to hide actually the explanation and the purpose of why these calculations are being made, what is their purpose, and what they lead us to. So, for example, if by making these calculations really hard, they actually make us to believe that these are scientifically true. This whole branch of science is based on the real truth. There is no kind of subjectivity in this branch, in this branch of science. So actually, instead of having it or considering it a social science, we may have to consider it a, basically a branch of natural science, so that all of the rules are being taken as it is. So one of the example is to, for example, is that learning model that how the traders are being traded in the markets. Instead of learning actually how they trade, instead of interviewing them, instead of observing them in the actual market, what the economists or the experimentalists do is that they just assume that this is the learning model, and based on these assumptions, uh, our model is going to just match the results that are being taken from the market. So they are not uh, taking the real world data, how the decisions are being made by the traders. They just assume that this could be the learning behavior that could lead us to the actual results. So, and while making these learning behaviors, they actually incorporate very sophisticated kind of mathematics in the models, just to lead us to the confusion that this is just the truth.
Yes.
Shall I proceed, sir?
Yes, please. Go ahead.
Okay. The next question is to explain how life expectancy data combines subjective values with factual objective information about the world, and how one can make more pessimistic or optimistic estimates. So basically, life expectancy has two kind of degrees in it: subjectivity and Then there is objectivity also. In terms of subjectivity, we are free to use the method of calculation, but assumptions are being made how the future mortality rate, we may consider it, or we may not consider that the mortality rate is going to change. So these are the subjective to us, that while we are going to calculate the life expectancy. And then the objective information is like, for example, these decisions are being made on the current mortality rate, the real data we have for now. So there are some degree of objectivity there, but the most part is it depends upon our subjective decisions, that how we are going to calculate, what assumptions are being made to calculate the life expectancies. So how one can make more pessimistic or optimistic estimates? For that, we just propose an answer that by adopting different measures like mortality to life expectancy, this has quite less expectancy as compared to other kind of measures, for instance, the median method. So it's up to us that which kind of method is going to be adopted, and depending upon that method, these we can reach, or we can uh, lead to pessimistic or optimistic results. Similarly, we can take different assumptions about the future, that whether the behavior of the persons are going to change in positive sense or in negative sense, whether it is going to impact the life expectancy positively or negatively. So these assumptions can also affect our results.
Yes, that's right.
And the next question is, what is the single biggest problem with estimating the life expectancy now by using the last century data? So if we have 100 years ago, the data set, and if we are going to compute uh, the life expectancy now, depending upon past data set, that what could be the single biggest problem? So to my best understanding, the biggest problem is that the future is uncertain. And what it means is that we are going to depend, or we are going to make decision or calculate the life expectancy 1 century ahead. So we are basically taking the data of the past and forecasting it for now. So this is the biggest problem, that over the time the factors are being changed that actually impacting the life expectancies. For example, the change in the behavior of people, again
So
health
actually, this is
innovations.
multiple factors. I was talking about one factor, and one factor is that life expectancies have been increasing. We can see it in the data. So if I say that the future is like the past, and the life expectancy today will be the same as the life expectancy yesterday, which is what we assume actually in calculations, that the mortality rate for 50-year-olds people this year will be the same. It will continue to do the same in the future. But the generation now will be 50 years later. So 50 years later, their health, their life expectancy, their health should be much better, or at least their life expectancy, or maybe medical treatment, etc., should be better. So because life expectancy has been increasing, and so when we assume that it is the same, this causes a problem. And so one of the ways that we can fix this is to look at how life expectancy has been increasing and use some extrapolation to adjust the last century data to match the expected rate of increase in life expectancy. Right?
Yeah.
That is why I said that there's one problem.
Yes.
This is a
Okay.
single problem, that life expectancy itself has been increasing in the data.
Okay, thank you, sir. So actually, to our understanding, we reached to the conclusion that future is uncertain, so it is the biggest problem in calculating the life expectancy. So now it is more understandable.
Okay.
So I think that's it from our side.
All right.
So
So
thank
let's
you.
go on to Group C. Who is presenting from Group C? Lisa?
Sister Nadia will share our result of discussion. Sister Nadia Hassan.
Okay, Nadia.
Assalamu alaikum.
Walaikum assalam.
Okay, let me share my screen. For this week's lecture, we had a few questions related to life expectancy. First of all, we had to take the dataset from the Excel file, and we were asked to identify the group of countries which caused the dip in the life expectancies during two time periods, that was 1972 to 1976, and again the second was 1990 to 93. So after some calculation, we have come to know that Mali was at the minimum life expectancy level, and by exploring some information from the history, we got to know that during 1972 to 73, Mali was hit by extreme drought, and subsequently there were political and economic conflict in the country, and such kind of situations always affect health issues and other benefits for the society. And similarly, for 1973 to 78, Cambodia, that was war hit during the Vietnam War, and from 1990 to 93, Rwanda was on the minimum life expectancy level. From all this information, we got to know that three different countries were there with the lowest life expectancy level. However, we cannot understand about the reasons without knowing about the actual situation in the country or their history or the real world issue. So we have
Very good. Yes.
included this real aspect in.
This is very good, and this is what I'm saying. This is the unique feature of this course, which is not done in normal statistics course. That we want to understand the reason behind the numbers. So the fact that Mali was hit by drought and conflict, and there was a Vietnam War and there was civil war, this is not in the numbers. No matter how much analysis you do of the numbers, you cannot explain why there is a dip unless you go to qualitative facts about the real world. So, and this is something which is not done in conventional statistics. So, okay, go ahead to the next question.
Okay, next we had to find out of 5 countries from 1960 to 2018 according to the life expectancy levels by identifying the maximum increase in the life expectancy, and later on we had to select one country, and we have to discuss about its situation. Now we can see that in 1960 there were quite different countries, and all countries have changed in the list of 2018. So we can observe that all the 5 countries which were in this list during 1960 are no more in 2018 for the top 5 life expectancy level countries. So it may indicate some health priorities or some health policies by the countries and some other factors that could have contributed to these new countries to top the list of life expectancy rankings. And now we were asked to identify one of those countries. I selected Japan, and 1960 to 2018 rank of life expectancy level of Japan is shown in this graph. And by observing this data, we can see that there is a almost steady increase in the life expectancy level of this country, and this might be indicating that health facilities or healthcare system is continuously improving over the period. And if we want to observe the reasons or some factors, we have again go to the real world and expand some of our lens, and we have focused that by reading some sources. I got to know with my group members that there was some policies by the Japanese government, and the salient feature of those policies were approval of legislation and efficient implementation of of the legislation. One of their unique policy was insurance of old age people. In conventional economic models, insurance of old age people is not considered to be very much beneficial. However, Japanese healthcare system was revolutionized by including this aspect, and the fundamental issue was they had provided extraordinary subsidies to those people, and secondly, they also introduced long-term healthcare plan, and this long-term healthcare plan was also settled in a ascending manner, like by increasing age, they started to provide more of the healthcare to their individuals and their people. So this might be a factor that brought Japan from 1960 to 2018 in a continuous increasing level of life expectancy.
Very good. You should notice that what is happening. Why did the Japan get this? He reached almost the top because they provided healthcare to the old people. The old people are the one who needs the most, and that is if you put your money into the old people. If you have a generally good any healthcare system, then that is the best way to increase life expectancy because the younger people will automatically survive unless they are has some accident. So that's one thing. And the other thing is that these subsidies, this is a natural in a traditional society that the young people take care of the old people. But in an individualist society like the USA or Europe, then the old people, there's nobody caring about them because the children are independent and they are not supposed to support their parents. Socially, there's no responsibility upon them. So then it makes life expectancy bad. So this is another effect of individualism and pleasure seeking as the objective of life. So the numbers are telling us stories, but statistics teaches you to be blind to the story and just look at the numbers, the conventional statistics. So we're trying to change this in our course. All right, go ahead. Next.
Okay, now in the next question, we are asked to identify the percent rank of one country and plot against its simple life expectancy. And basically, percent rank is a way to identify the position of a number in a given list. So if we find any value, as it is mentioned already, 80% refers that country is performing better than 80% of other countries, and only 20% of that country are better. So percent rank is an efficient way to make a comparison. Simple number like life expectancy can only describe us the status of or situation of the healthcare system in a country. However, we cannot make any comparison, or we cannot go to some other conclusions, or relative measure is percent rank. So in case of Pakistan, not only by this we can see a simple number can show a steady increase in the level of life expectancy here in case of Pakistan, and similarly we can see that percent rank of Pakistan actually is representing the position of Pakistan in the world regarding life expectancy. And we have very fluctuating position. Initially it was lower, and then there was some increase during after 1966, but later on we have declining pattern with some fluctuations, and up to 2017 there was a dip, and again 2018 a little higher, but we are not better. Initially after 1960 we were in better than almost 36% of countries. However, in 2017 and 18 we are in bottom 20%. So this provides us an efficient way to observe our progress, and we can identify our problems, and we can then provide policies to resolve that kind of problems.
Yes, good. If you look at the life expectancy graph, you see that it's smoothly increasing, and you say, "Oh, everything is fine." In Pakistan, we are getting steadily increasing life expectancy. You don't discover any problems. But if you look at the percentile rank, you see that it was going up from 60 to about 70, and then it started declining from 70 to 1990. It went up for a little bit between 87 and 93. Then it was flat between 93 and 99. Then it has been on a declining trend. So this is when you compare it to other countries, then you can see more interesting things. Why is Pakistan not? All countries have been increasing life expectancy. So what this is showing is that we are not keeping up with the rest of the world. So there's something wrong with our health systems compared to what is happening in the rest of the world. So something to look at. Basically, this is the methodology of real statistics, that the numbers provide us with a clue to something that is happening in the real world. Then we have to go to the real world. We have to ask what is Pakistan doing wrong, and what are other countries doing right that they are doing better than Pakistan. And so for this, you can't, the numbers will not provide any information. You have to expend shoe leather, as they say. You have to go walk around, talk to people, look at books, because the data is not available on many things. You have to go and talk to people and learn what they think, and from that you can learn something. All right, so next question.
Next, we have to identify top 10 countries by each decade, and last one, the latest year 2018, that was in the Excel sheet. And we had to find out that the group has been changing or not, and who have been the best performance according to life expectancy over time. And similarly, we also had to identify low income countries exist in top 10 or not. But from 1960 to 2018, each decade has shown that only developed countries that are listed by the World Bank WTI ranking high income countries are in this top 10 list. However, the list is varying continuously. We can see that initially some countries have sustained on this list for some of the decades. However, later on, if we come to 2018, only a few countries could survive. And one of those is Switzerland. Switzerland has continuously in the top 10 list from 1960. It has sustained its sixth position, and later on it has declined to one position to seventh, but in 2000 it was again on sixth position, and in 2018 it has sustained its improved its position to number 5. And now if we see that there are few countries that were not in the list until 1970, like Japan, and Japan has topped the list for the subsequent 2 decades, 1990s and 2000, and even in 2018 it is almost in the top and on the second number. However, Singapore, Italy, and Channel Island, these are new countries on this list, relatively in the latest decades. But the trend I have observed, and we have discussed in our group, that high-income countries are only in this top 10 list, and we can identify the reason by observing some real-world situation and some economic theory as well. And we can see that there might be a link in income and life expectancy or health standards of the countries. However, it needs further exploration regarding the allocation of resources and facilities or opportunities available to develop a good healthcare system.
Okay, that's fine.
Okay. The last question is about life expectancy. Unlike the wealth, cannot have extreme outliers. Therefore, a small group of people with long lives cannot cause a huge bias in the life expectancy, and so this number is more reflective of the general population than GNP per capita. And we were asked to explain this. According to our understanding, actually, GNP per capita is an imaginary measure of the wealth, and it does not exist in reality, and it is never possible to bring into reality. And basically, GNP per capita requires us to collect all the wealth of a country and equally distribute among the population, and it is practically impossible forever. So there will be more bias and more illusions created by such a measure. However, if we come to the life expectancy, it calculates the probability and expectations by using some real data. because real data is also used in calculation of GNP per capita, but those real data may not be materialized in the real world. However, life expectancy is probability, and we only calculate the expected number of years a person can survive. So it might not create a huge bias or outliers as compared to the wealth.
Yeah, you see, you can't have people who live 1,000 years or 1 million years. So that's why you can't have outliers. But in wealth, you can have, most people have 1,000 rupees, but somebody has 1 billion, 1 trillion. So then you have huge outliers. So if you have all of the population is poor, but there's 1 billionaire, then he will raise the average of the whole population. So, but this cannot happen with life expectancy. All right. So this is good. Thank you. Nadia, I think now we are at the last group. Is it?
Yes, this was last one.
Yes. Okay, so group D, I think, is it? Now the turn for group D. Who is presenting from group D? Is there somebody from group D here? No. Is Amna Uruj here?
Assalamu alaikum, sir.
Walaikum assalam.
Group member
So-
Imtiaz was supposed to present, but I can't see him. I think he's not online at the moment.
Okay. So you have the document? Oh,
Yes, I can present some preliminary answers up to my understanding.
that's fine.
Okay, let me share the
Uh,
document.
Is there Mike has his hand up? Is there something that you want to say?
No, I
Mike?
don't know.
All right.
It's not. I don't think it's my raised hand.
All right. Okay. Go ahead.
Okay, let me share. So I'm having some issue. I need to restart my computer. My
I see.
documents are not being showing here. Just for in a moment, I'll be back.
All right. Go ahead.
Or
I
I'll,
think
I've shared it. I've shared the document in WhatsApp group.
yes, I have the document. I will start up on it, and you can
Okay,
you
okay,
can go off
okay,
and on. I will make a start, and you can join when you are
okay. I'll be back in a minute.
okay. I'm going to present my screen. All right. So I'm going to share my screen while we are waiting for Amina. Okay, let's see now. All right, now I've got this thing set up, and
Uh, Sorry to interrupt, sir. Your voice is not audible. I think the mic has been muted, sir. So the mic has been muted.
Hello? Can you hear me now?
Yes, yes, sir. We can hear you now.
Okay. All right. So Amna, are you back? All right. So this is the first histogram which has an auto bin that has been made with the automatic default. And when you basically, you see, one thing that I want to understand, want the students to understand, is that the reason that modern statistics was developed along the lines of which Fisher did was because people could not look at the data. Very simple. See, we have a huge number of numbers. If you look at those numbers, you say, okay, draw me this graph. All right, so this would take many people a lot of, maybe one day of work to draw this one graph. And in Excel, you can do it in a minute. So you can look at the data in many different ways to understand what it is trying to tell us directly. So basically, this is the key, that in the Fisherian approach, the conventional statistics, you make a lot of assumptions. So for example, you could assume that the life expectancy is a normal distribution. Then you can make some graphs about that, but they are not about the data, they are about your assumption. So because we have the ability to look directly at the data, we don't need to make those assumptions. And so basically what we are trying to teach in this course is to look directly at the data and to understand. Of course, actually, we cannot also look directly at the data. If you look at the Excel spreadsheet, you won't understand anything. So when I say to look at the data, I mean that you can graph the data in various ways to understand what the data is trying to tell us. So here the data is telling us that there are two types of countries. And here the data is telling us that most countries have, by the modal bin, most countries have life expectancies between 70 and maybe 80. I don't, the bin sizes are not given, so I don't know. But yeah, I guess it's about 12 years. So this will be between 72 and 84. So with the different bin size, then the biggest bin. So this tells us that most of the countries are in the largest life expectancy, and then there are fewer and fewer. So on the basis of this graph, I would say that, okay, if some countries are in the bottom category, so this is going from basically 42 to 52, or maybe it's, if this is the midpoint, then it will be going from 38 to 45. So we should look at these countries. They are doing very badly. There are very few of them. It looks like there's maybe only one country in this range, or maybe two. So these countries, we have to look what is happening, something very strange, because nearly all of the countries are better than that. Then we can look at this. These are the failures. This is the grade D, and this is the grade C, and this is the grade B, and this is the grade A. So in all countries, so if we look at a grade B country, we can say, okay, they are doing good, but they could do better. Lots and lots of countries are in grade A. So then we can say, okay, what are the things missing in the grade B country, which they need to learn from grade A? But again, all of these questions, they are not part of your data. They are things that you have to go into the real world to find out. As you start increasing the bin size, then you start getting more details. So here the bin size is very small. So we see that there is a median country, there is a second median emerging. And here we can see that there are a few countries with a small life expectancy, not just one. There's one here, and then there's 1, 2, 3, 4 countries in the second. So these are the worst countries, and they're separated by a gap. So there is something very exceptional. These are outlier countries, these 5. So we should, if we want to improve healthcare in these 5 countries, it should be relatively easy because they are so abnormal. Something very simple should be, because all of the countries are doing better than them. So it should be possible to find easy ways to improve life expectancy in these countries. This is with bin size 2. Okay, so then the second exercise has you making bins like this. One of the things that I wanted to do with this exercise is to get people to understand how to make histograms first. So this is the technical part. And then how to interpret histograms. This is second. This is more difficult. It requires practice, thinking, and so on. So the technical part is easy. Here we have bins. We are making 2020. Oh, Amina, are you back?
Yes, sir.
Okay. So you can take over, and I think we are near the end, but you can come in and tell me and ask
sir.
me, and if you have a question. Yeah, go ahead.
So from the first 2 questions, they were mainly the technical questions that ask us to practice the construction of histograms. But the interesting fact from these 2 questions that can be noted and understood is that using different bin sizes provide different insight about the data, and the smart thing is to identify which bin size we select to use to present or summarize the data set. It can be seen that using too large bin size would summarize the data so much so that it may hide many interesting details from the data set, and using too small bin size would provide us some details which may not be of our interest, but still the using small bin size would be helpful in identifying the outlying observations or some unique details or uniqueness about the countries. In this case, the countries with some extreme life expectancies, and may be helpful in identifying or exploring the reasons why these countries have the too low or too odd life expectancies. Like in this case, the chart at the moment on the screen, that it can be interesting to look out which country is the one having the life expectancy as low as 43.85, and why is the country or countries as having so low life expectancy. But this is something that need to be explored, that requires shoe leather and is needed to be explored outside of the Excel spreadsheet. The next question was about looking at the since the data set comprises of several countries or several years, so just looking at the numbers may not be of much interest unless and until we explore what these numbers are telling us about, or with which countries these are related to. So looking at some summary statistics could have been a better choice. For example, looking at the median country for a specific year, and then exploring which countries on the basis of ranking are lying near or at extreme ends of the data sets. We have done this for the case of in form of 2 splits of data set. First one was the case where we have observed the whole data set, and we have followed on calculated the median for a median of life expectancies over the time period of 1960 to 2020 for the whole data set comprising of more than 150 countries. And in this case, still the median was telling us a consistent rise over the in life expectancy over the years. But it was, although it was a supposedly indicator of the improvement in health conditions across the globe, but the answer wasn't complete just by having a look at the median. So we selected 3 countries, one near the median group and 2 countries from the extreme ends. And it was noted that Nigeria and Japan were the countries that was identified on the basis of the ranking from year 2020, that these 2 countries were near the 2 extreme ends. And we can see from the graph that since the graph was providing us overall summaries, so we can see that these 2 countries were having a consistent graph of about the life expectancy, that Japan remained throughout above the median country group or in the third quartile group, while Nigeria was the country that remained in the first quarter, showing the lesser performance referring to the health conditions, or the country having lesser life expectancies. But later on, we followed in the next part of the question, आगे वाली slides में आएगा वो, that where we have noted that selecting or splitting the time period for a smaller group of years, that is about 2008 to 2018, the situation was a little bit different. And the last question was about exploring the situation that if we are interested in drawing some health policy, so what would be more important to look at, looking at a larger range of data set or looking at a smaller range of data set. The largest data set, the first graph, or the graph on the left hand side, covers up the larger range of data set. Here we have selected the median class and 5 countries from the top 10 group and 5 countries from the bottom group of bottom 10 countries. The behavior, the general behavior remains the same, that the countries belonging to the third quartile remain in the top set, and the bottom countries remain in the lower set across the larger time period. So in the case of life expectancy, splitting up the years in over 1960 to 2020, or looking in the smaller looking at the smaller group, that is between 2008 to 2020, is seemingly not providing us anything reference to the data set, because the countries remain throughout, the chunk of country remains approximately the same. But अगर हम थोड़ा सा नीचे जो countries का name है उनको देखें तो हमारे पास ये pattern change होता हुआ नजर आता है. The set of countries which remain in the top 10 for the larger data set aren't exactly the same ones in the smaller group, although majority of them remains there. And similarly, majority of the countries remain in the same lower or bottom top 10. In case of the situation, I think that looking at the recent or the smaller chunk of years, or the recent 10 years, would be enough for developing a health policy. However, you can provide, और आप बेहतर बता सकते हैं कि इनमें से कौन से ग्रुप को देखना बेहतर होगा, because the policies over years have been drastic or have been given drastic changes. अगर हम 1960 to 2020 देखते हैं तो हमारे पास बहुत ज़्यादा health policies में change आता है, लेकिन इसकी reason सिर्फ और सिर्फ जो है वो life expectancy का natural change नहीं है, बल्कि there could be several other reasons or variables which are not studied under this Excel sheet, or which are not being covered just under the variable of life expectancy. So to me, looking at the data set from 2008 to 2020 for drawing up the health policy could have provided better insight.
Yeah, well, I think that these graphs are not giving information about the issues that we want to see. And one of the things that you need to learn in this course is how to look at the data to find something interesting. So, for example, one of the things that you would look for is a country which is climbing in its percentile very fast. It means that it's improving. I mean, there is some general process which is going on throughout the globe, which every country is benefiting from. So that's something we can't do anything from. But if some country is exceptional, and I think that when I last analyzed it, Iran had an exceptional performance, and there were a few other countries. It starts out in the bottom half and moves to the top half. So then we can ask what did Iran do which caused it to change, and then we can go and look at health policy in Iran, and there are others. So anyway, one of the things that, I mean, how to look at the data depends on your understanding of what's happening in the real world, and that's something that we need to learn more about. All right, I think this is all, and we have almost run out of time, but there's one more group left, so let's go ahead and do the answers for the last one, group E. And I think there's one more section which we will leave until the next time, maybe, because we are out of time. So who is presenting from, let me stop the share. Okay, so I'm stopping the sharing and go back. And who is in the group D? Okay, Seth.
Seth here, yeah.
Go ahead.
I think I need permission to, sorry, so I've joined as two people. Could you give permission to the other? There might be another Seth.
All right, let's see.
Yeah. Yeah, there you go. I got it.
Okay.
So is this visible?
Yes, we can see it, your screen.
Okay. So we were asked to take the data for life expectancy, which is LE, and the gross national income at purchasing power parity, and compute the ratio of these two, because this ratio indicates the extent to which a country prioritizes increasing health and life expectancy. It's the ratio of money spent, it's the ratio of life expectancy to the sort of total amount of income that a country has, corrected for purchasing power. So I chose the data for 2017, and if you remove missing values, etc., so we were left with a data set of 182 countries. And the top 10 countries were these on the left: Congo, Ethiopia, etc. And the bottom 10 countries were United States, Bahrain, etc., etc. So, of course, the immediate interesting thing was that the countries that are the richest and have the highest life expectancies are at the bottom when you change the measure of the that you're looking at. So if you just look at LE, then these countries were on the top. But if you look at this ratio, then the countries that are on the top are mostly in Africa, South America, Central America, Asia, etc. So then
how do we interpret this?
Yes, so how do we interpret this? So we were asked to draw a histogram of the countries. So I mean, well, the way I interpret this is that basically it's kind of like bang for the buck. Like how much life expectancy could you add based on how much you had? So these African countries, in terms of, so we can say that they exhibited much more competence vis-a-vis spending the whatever money they had on increasing life expectancy. The one thing I feel is that life expectancy, I think the relationship is non-linear. So I think it's easier to go from, say, 60 to 70 than it is to go from 80 to 90. So maybe that's one thing. So that's one thing. Maybe that these richer countries have a slightly harder problem. So I drew this histogram. So I think this is also just auto bin width. So this is, the bin width is 0.02. And the range of this ratio is from 0 to about 0.13. So we had 7 bins. And there were 3 countries in the top bin and 89 in the bottom. And so again, like the countries in the top bin are the ones that I've already said, you know, the African countries, and the bottom ones were sort of more the richer countries. So then we were asked to look at pairs of countries that had similar, that were similar, meaning geographically, economically similar, etc., but then achieve very different outcomes vis-a-vis this ratio. So two countries that I found were Libya and Sudan, and they're shown on the map here. So they are somewhat the same size. They are neighbors, kind of coastal countries in northern Africa. Whereas Libya got a score of 0.003, and then Sudan had a 10 times higher ratio. And the difference is coming from the denominator. The income of Libya corrected for purchasing power is about 21,000. I forget the units, and Sudan is 2,100, so it's 10 times less. So even though the life expectancy for Sudan is 64, they did much better because they got there with a lot less money. So the question was, well, why is this? Why could this be? So I looked at some figures, economic, what determines life expectancy. So there were certain factors. So in terms of health expenditure, etc., Libya actually did better than Sudan, health expenditure and health expenditure per capita. But the countries are very different in terms of environmental and lifestyle factors. So forested area as percentage of total area is 0.1% in Libya versus 11% in Sudan. And then CO2 emissions per capita in Libya are way higher. They are close to 16 times higher than Sudan. And this was the 2017 from the World Bank data. And then the number of vehicles per 1,000 people in Libya is 433 compared to 2.85. So this could signal, direct effects of just having carbon dioxide in the air. Versus it also signals a more fast-paced kind of lifestyle. So possibly some relationship with, heart disease, etc., that tax life expectancy. And similar kind
Very
of
good.
argument.
I want to just make a comment here, and that is that, learning about the world is like a detective work. So you put out some hypotheses, and then you can chase them up. That is it really this? What is the effect of this factor that you have identified as a potential reason for this difference? And then you can study it further to see how much difference it actually makes across a large range of countries, and see if this could be the cause, or maybe it could not be the cause, because it varies a lot across countries, but it doesn't affect the life expectancies that much. So it is very much like detective work. You have to follow up clues, look at more clues. Then, okay, so go ahead.
So in this case, building off of that, this argument also holds for Trinidad and Tobago and Haiti. There are similar countries, produce similar amount of GDP, but Haiti has more than 10 times on this ratio. And again, carbon emissions are, I don't know how many times higher, like way thousand, like hundreds of times higher in Trinidad and Tobago versus Haiti. And I did find research literature which says that carbon emissions have a direct causal impact on life expectancy, and the coefficient was significant and negative. So there is some prior evidence, and for the two pairs of countries that identified, both the argument sort of holds for both of them. And that's as far as I got. Yeah.
Very good. So I think we will call it quits because it's 7:30. Did anybody actually do? There's one more section in this. Last time, I think Tasir did 2 sections, E and F, but this one was a bit difficult, so probably no one did that. So what I would like to do is to assign one question each from the last part, the section F, to each of the groups, and you can make up a short video answer so that I can share with all of them. So put up a PowerPoint slide with the answers and do a recording on it, and that will be the answer, and then we will share this across the groups. So there are about maybe 4 or 5 questions that are left. These are in section F, and so I'm going to give this to all of the sections and try to engage one of the students who has not presented yet, so that we get bigger participation from all. So I hope that this was fruitful to the students to understand how Actually, only those people who have taken statistics before will understand how this is different from conventional statistics, because we're not discussing analysis of numbers in isolation. We are discussing how the numbers provide us with insights into what is happening in the real world. But to do this, we have to follow up on what the statistics is saying by expending what one David Friedman has called shoe leather. You have to actually walk around and see what is happening. All right, so very good. We will call it the end for this lecture, and we will be back in 2 weeks with chapter 5 on Sunday. And in the meanwhile, I would like to ask the solutions to the last section, which we didn't do. One question each for each of the sections, and you can take it in order so that the A does question 1 and B does question 2 and so on. Okay, is that clear to everybody? All right, so good. So thank you all, and we will see you next week in 2 weeks. Jazakallah fi ddarain. Assalamu alaikum wa rahmatullah.